Okay, so today we're going to start talking about complex numbers. And complex numbers are also known as imaginary numbers. And if you think back to that chart that we made a long time ago, we made a real number chart where we had the squares and the rectangles and we cut them out and we put them in order, and we had things like rational and irrational, and then we had all the different types of numbers like integers and all that good stuff. Imaginary numbers do not fall on that chart. An imaginary unit is I, and it is defined to be I squared equals -1. And that is because I is equal to the square root of -1. So if we think about I squared, that would be equal to the square root of -1 times the square root of -1. And if I put that under the same radical, remember, when we have a square root, we take out pairs, and when we take out pairs, a pair comes out, but remember, only one survives. So we get -1. So therefore, I squared is equal to -1. So remember, I is equal to the square root of -1. I squared is equal to -1. Okay? So numbers that form 6i, -2i, and I squared of 3 are pure imaginary numbers. And pure imaginary numbers are the square roots of negative real numbers. So anytime we have a negative number under a square root, to deal with that, that's where the I came into play. Because we can't take the square root of -27. We can take the square root of 27, but not -27 without having an I to deal with. So if we have the square root of -b squared, we can break that down into the positive part and the square root of -1, and we know that the square root of -1 is I, so I can then do the math over here, and I know the square root of -1 is I, so it's whatever I get here times I, or BI. Okay? So here's how they work. If I have the square root of -27, we take what we just looked at here, and you break it down into the square root of 27 times the square root of -1. I know the square root of -1 is going to be I, and then I can come over here and I can break this down into primes, doing your little upside down division thing. A prime number that goes into 27 is 3, and we get out 9. 9 is not prime, so we keep going. I can divide by 3 again, and I get 3, and 3 is prime, so I'm done. And then when I come over here, I've got the square root of 3 times 3 times 3. And then I take out, we're doing a square root, so we take out pairs. There's a pair of 3's that comes out, only one survives. And then we have the square root of 3. Now this I is hanging out over here. We always write it like that this is its coefficient. Okay, so 3i square root of 3. So we just pull that square root of -1 out and it becomes I. And then we're back to doing what you did back in junior high, square root of 27. You break it down into primes, pull out your pairs. Okay? So over here I have the square root of -18. So we break that down into the square root of 18 times the square root of -1. So I go over here, I break down my 18. Prime number that goes into 18 is 2. We get out 9. 9 is not prime. The prime number that goes into 3 is 3, or goes into 9 is 3. So here for square root of 18, I have 2 times 3 times 3 times the square root of -1, which we know is going to become I. So I bring a pair of 3's out. So I have 3i coming from here, and there's a 2 left under my radical. Okay? When we go down to where we're multiplying, please remember, when you multiply radicals, you can write everything under the same square root. So I can break this down into 6 would be 2 times 3. 15 would be 3 times 5. And then I have a times the square root of negative 1 times the square root of negative 1. Okay? And we know I'm going to bring a pair of 3's out. So I have 3, and then square root of 2 times 5 is 10. And negative 1, square root of negative 1 times the square root of negative 1, remember, that's I squared, which is just negative 1. So that would end up being negative 3 square root of 10. Okay? Number 4, we have the square root of negative 20 times the square root of negative 12. So if I break 20 down into primes, prime number that goes into 20 is 2, and that gives me 10 when I divide it out. I can divide by 2 again, and that gives me 5. So I have 2 times 5. For 12, I can divide by 2 and I get 6. I can divide by 2 again, I get 3. So 2 times 2 times 3. And remember your negatives, so you can even write it like this, would be totally legal. And so when I go back and I look at it this way, if I look at pairs, if you don't see it in the I thing, I've got a pair of 2's, a pair of 2's, a pair of negative 1's that can come out. Please remember, when those come out, only one of the pairs survives. So I've got 2 times a 2 from this pair times a negative 1, and under my radical I still have 5 times 3, which is 15. So 2 times 2 is 4, times negative 1 is negative 4 square root of 15. Okay? All right, when we multiply imaginary numbers together, think of this as, treat it kind of like a variable. So if I have negative 5i times 3i, I can multiply, if it said negative 5x times 3x, you would do negative 15x squared, right? And we would leave it alone. But here, I means something. So I'm going to do 5 times 3, negative 5 times 3, which would be negative 15, and I times I is I squared. But we know that I squared from back at the top is the same as negative 1. So I have to look at it as negative 15 times negative 1, which would give me positive 15. Okay? And then I have 3i times 4i. Well, 3 times 4 is 12. I times I is I squared. And so 12 times I squared I know is negative 1. So 12 times negative 1 is negative 12. Now, you can also put this in your calculator. On your calculator, the I is right above the decimal, and it's in yellow. So you would press second decimal, and you could put it in just the way it's written. And you would end up with 15. You could put this in just the way it's written. You would end up with negative 12. Just like here, you can do I to the 23rd power. You would do your I button and caret to the 23rd power. Now, if you wanted to do it by hand, there's a pattern that goes on. So here's what you need to look at. You would have I, we know, is the square root of negative 1. I squared is the square root of negative 1 times the square root of negative 1, which is negative 1. I to the 3rd power would be I squared times another square root of negative 1, so it would be negative I squared. Sorry, not negative I squared. It would be negative I. I to the 4th power would be I squared times I squared, so that would be positive 1, because it would be negative 1 times negative 1. I to the 5th power would be 1 times the square root of negative 1, so it would just be I. I to the 6th power is going to be I times the square root of negative 1, so it would be I times I, which is I squared, which is -1. And then I to the 7th power would be -1, because this is I to the 6th, and we're just multiplying by another I squared, or square root of -1, I'm sorry. So it would be -1 I, because I is the square root of -1. And you see how the pattern is starting to repeat? So I to the 8th would be 1. I to the 9th would be I. And you could go on and you could repeat that until you get to I to the 23rd. But I to the 23rd if you put that in your calculator, so I to the 23rd would be -I. Okay? Okay, so if we're going to solve equations with pure imaginary numbers, the first thing we're going to do is we're going to get x squared by itself. So over here, if I wanted to solve for x squared, I would subtract 64 from both sides. And 0 and -64 are like terms, so I would have x squared equals -64. So remember, once we have x squared by itself, then we can take the square root of both sides. And remember, when we take the square root, that it's plus or minus. So plus or minus, and I take the square root of -64. Well, the square root of 64 is 8. And to take care of that negative, remember, we bring out an I. So it would be plus or minus 8i. So that means that on a multiple choice test, it'll be looking like this. But please remember, this is what this means for plus or minus. It would be -8i or 8i. And this big picture would be a parabola. These are the solutions for a parabola that does not cross, or a quadratic equation that does not cross the x-axis. So over here, when I'm looking at this one, 4x squared plus 100 equals 0. So remember, step 1 is to get the x squared by itself. And step 2, take the square root of both sides. Don't forget the plus or minus. Okay? All right, I'm going to go ahead and stop this video here, and I'll pick back up on a new video to do the rest of the notes.